All right, so in section 2 of chapter 11, we're dealing with comparing means, and we're looking at the dependent samples, I believe, in the first section, and then in the third section, we'll look at independent samples. But, so what it means to be a matched pair, that means they were related to each other. Similar how in the first section, if you were asking the same people the question, that's why it would be dependent. And these, there has to be some commonality. Let's look at number 3. The accompanying data represents the muzzle velocity in feet per second of rounds fired from a 155 millimeter gun. For each round, so there is 2 rounds, 2 measurements of the velocities were recorded using 2 different measuring devices with the accompanying data obtained. How many guns were there? There was 1. Both are being fired from this same source. So that's why this one would be a dependent. We are matched pairs, what we're going to call these. And so why are these matched pair? The same bullet was fired in every round? No. 2 measurements may be taken on the same round? No. All the measurements came from rounds fired from the same gun? Yes. Right? So we're dealing with the same... Whoa, not correct. The measurements A and B are taken by the same instrument. There's 2 measuring devices. 2 measurements A and B are taken on the same round. 2 measurements of the velocity were recorded using 2 different measuring devices. Oh, totally wrong. I get them wrong too. So 2 measurements A and B are taken on the same round. So it's the same bullet, and then we have 2 different measuring devices. So let's check that one, and hopefully that one's right. So Boone makes mistakes too. Boone makes mistakes every day. So now we're looking at the mean difference. It's a different way it's set up, mean difference. We're still going to have an equal to always on our null hypothesis. So we know that one's wrong, we know that one's wrong, we know that one's wrong. But what is the other value? Is there a difference in the measuring of the muzzle velocity between A and B? And so if we look at this one, it just looks like we have 2 of them. We think they're different. So that would make me conclude that I would use E. Is there a difference, right? Nice work. Cut that one right. So now we need to find the p-value. So we have to look at our data, right? So we have all this data, 1, 2, 3, 4, up to 12. So let's move this into StatCrunch. So they did not give me a summary of data. They gave me the data, right? So here's all my A data, here's all my B data. Now, when I am doing this in StatCrunch, when it says match pair, that means paired. So in the next section, section 3, we'll talk about to sample. But this one is paired data. So my column 1s will be A, my column 2 will be B. I could save the differences. That's what I'm looking for. The differences between each round in the measuring devices. How far are they off? We said equal 0 and not equal 0. So this is consistent to what my math lab is saying. So sample 1 in A, sample 2 in B. Again, I'm going to tell you it is important to make sure that we are saying A is the first one, B is the second one. With these, so I think we are good there, especially when it comes to greater than or less than. And we are going to compute. So it gives me a t-stat of negative 0.535497. So I think these are asking for how many decimal places? 3 decimal places for the p-value. Oh, I was doing the test statistic. The p-value is 0.603. So if I go back to here, my p-value is 0.603, right? So let's also look at the table again, just to see what we're doing. The mean difference is 0. The difference between this one is 0.1. The difference between this one and this one is negative 0.7. And so what we're testing when this measuring device measured the bullets, and this measuring device measured the same bullet, like those are the same bullet, these are the same bullet. Were they roughly the same? That one was close, that one's a little bit off, but are they roughly the same? Is the difference, the mean of these differences, about 0 is what we're looking for. And so we got a p-value of 0.603, which is a pretty high p-value as we've discussed. So would I reject or fail to reject? And you are correct. You do not reject the null hypothesis because there is not sufficient evidence. You do not reject the null hypothesis. There is not sufficient evidence. A 99% confidence interval about the population mean difference. So now we're looking at a confidence interval, which we can do. We go back to our data and we can create, going to the same place, t-stat paired, sorry, we still have A and B, right? Let's just do a confidence interval, right? And it wanted us to be 99% confident. And we should be good to go. Lower limit negative 0.566, 0.3999. So let's see how many decimal places. 3 decimal places. So negative 567 to 0.3, looks like 400 is what it's going to be, 400. So let's check that, and then let's understand why we did not reject. So that's correct. And it's correct because 0 is in between here. Like if 0 is not in between, is not in our confidence interval, then we can't say that the mean difference is not equal to 0. 0 is in between our confidence interval. This is negative 0.56 to 0.40. That's an acceptable range, right? When we did our statistics, we got a mean difference of negative 0.08. That's pretty close to 0. And by pretty close, I mean close enough with the number of data points and everything that we have to say that we still believe that the difference between these two measuring devices is super small and they roughly measure the exact same. That's what we're saying. We are 99% confident that the mean difference is one of the differences, no, between the two values above. That the mean differences in measurement is between the two values above. Oh, the wording. We are looking for the mean differences, not the difference, the mean difference in measurement, and not of the sample. We're trying to conclude something about the population, so that's why it's not this one. And that should be correct. I'll cross my fingers. Good. Draw bot plots of the difference data. So we could do that because, again, we already have our data. And I want to do a box plot of it. This takes us back a little while. So a box plot of our differences. And let's go horizontally because that's what I think they did. Bam, there we go. There's our box plot. Which one does that look like? No idea. Maybe look closer to this one. Just from, I saw that the median was further to the left. So I'm going to take a stab, and I got it. One more part, support the result obtained. Yeah, because 0 is maybe in that inner quartile range, right? So I kind of like that. It's real close to 0, our inner quartile range. So I'd say, yeah. Sweet. So that's how you do one of these dependent sample ones, a matched pair design.